Hello.
Hi. Shavai, it's early for you.
No, I guess it's already 7:30.
Yeah. No, I just mean, since we've had conversations at like 4 a.m. your time, I figure
Yeah.
I figure it's about lunchtime for you right now.
No, actually, I tend to sleep at around 7 a.m. my time and then get up by 11. That's like nowadays usually happening.
Oh, okay. Wow. Man, I thought Kanishkar had it bad. And Naveen has been up pretty late as well. But yeah, I think you might have the. I don't know if that's something that you want to win or not. But you might
No,
be
because
the.
I mean, usually it's like that is the time when I can really focus on the work because there's no disturbance.
Yeah, totally. I don't know if it's this way for you, but for me, we have a rooster, and that's about the only disturbance that we have in the countryside that I live in. So nice. It's nice. All right. Meeting minutes. Meeting minutes. Meeting minutes. You're looking at today's date. Kind of surprised that I'm just kind of waiting for it from one of you guys. I'm not sure who's going to do it, but just again, kind of looking at what today is, at least in the U.S. What today is. Or you know what? So I'm trying to hunt down the meeting minutes. If anybody's got that link, I think it's inside the general channel, the Meshery channel. There it is. All right. Oh, there it is. Very good. I also just now realized that I was probably making a really bad joke just then. Today's April 1st. Does April 1st bear any significance for you guys?
No, not really.
No, okay. All right, then yeah, it's a horrible joke. So April 1st in the US and maybe some other countries, I don't know, but in the US, it's called April Fool's Day. And
Yeah.
okay, yeah, you're familiar. So anyway, this morning my one of my sons and I tried to trick my wife that we tried to trick her, didn't work. It was gonna be really funny. She's not gullible, so it didn't work out. It's frustrating. Okay. All right. Good. So Nikhil was with us a moment ago. I expect he'll be back. I'm sharing the meeting minutes now, so hopefully everyone can see those. Please do jump in and help if you would. So, what topics do we have today? I've got some, but I'd rather that you guys were bringing them up. Push. Push. I haven't written out your last name enough to have it memorized. Ready? Good. And then we have Vineet Sharma. Hey, Vineet, a couple of things. One, great to have you here, Vineet. So excited. We've been talking a little bit, but since it's your first time on the call, do you want to, if you can, maybe take a moment and introduce yourself so you can get to know some of the other guys in the community?
Yeah, surely, sure.
Nice. Good.
So hi all, I am Vinny Sharma. I am at present pre-final year CIC undergrad at IIIT Sri City, and my areas of interest include cloud native and distributed computing. And my past works have been in full stack development using Vue.js, React.js, and Django. And recently, I took a course in cloud computing wherein I got to know about Docker, Kubernetes, and service mesh. So after going through some of the articles and blogs on service mesh, I got interested in this topic, and then Lee approached me on Slack. He told me about Meshery, and I was just amazed by like this is what I want to work on, and like I look forward to this community to contribute in open source and like make some good contribution in Meshery. So yeah, thanks.
Oh, yeah. Nice. Very good. Okay. You're in good company, actually, with each of the other guys here. Shivai,
Yeah,
Naveen, Anand. Yeah. I think Anand is the graybeard here, actually. I think he's, well, that Anand and Shubham, who just joined as well. Both of these guys have been around for, for about a year, I guess. Too long. At some point, they're going to either get bored and leave, or we're just going to have to, kick them out or something. I don't know. Anyway, Vineet, it's good to have you here. It's great. We were just this week kind of busy finishing up submissions for Google Summer of Code. So Naveen, Kush, Shivai, Ashish, and Kanishkar. I know that they all submitted for sure. And so I'm going to keep my fingers crossed that we get as many open spots as we're looking for. And if we don't, then I'm going to have some conversations with each of these guys about how to engage anyway. So good. So that's kind of a topic with GSOC. The nice thing about the GSOC proposals is that it has forced us to get a few things on paper that we didn't have on paper before. Helped us get a little bit organized. I might suggest that we talk about a couple of the topics in those proposals. But before doing that, let me ask if anybody's got something else to chat through. I'm going to write down a few things.
I guess like like since I would say that a lot of us were trying to get in touch with like Envoy, and so yeah, I mean, like if we can get started with at least initial testing of how like which all services we can use, for example Nighthawk, or like which all we can use, at least for those students who are selected for GSOC, even they can have a brief overview before that. Like I think we can have a small discussion on that. Like because there were a couple of people who were talking about it during the in the Envoy section, which you have shared a issue, right? So we can have a small discussion on that.
Nice. Very good. Okay. I'm going to share my screen again. Yeah, I agree that there were a few of us that were interested in advancing that proposal or that piece of work. And it's actually something of an exciting piece of work. Should I mention the topic of distributed performance testing? Very good. All right. So Anand, actually, just because your topic is a relatively short one, just real quick, of the three UX improvements that we talked about on, for Meshery CTL Perf, it would be good if we filed just 3 quick issues on those. So I think those can be done maybe independently or all at the same time. And then sometimes I forget. I think on this call, Anand, you're not necessarily in a position to do audio. So of the 3 improvements, I think these were the 3. So for any of you who have used Meshery CTL, the CLI for Meshery, there was a new subcommand added recently, perf, and it was added hastily, which was great. Kanishkar was the one that added it. He went through it quickly, and then it was acknowledged that there were some loose ends. And so, Anand, it's good if you end up finishing those off. Yeah. Nice. Okay. Yeah, you've got a microphone problem. Okay. Okay. Good. So Shivai, the topic of distributed performance testing, this is an exciting one. Actually, of the topics that we talked about for Google Summer of Code, let me see if I can find that. Everyone has access to the Meshery team drive. In there, I believe it's under community. There's a GSOC folder. There's a couple of, some of your proposals I think are in there. But there's also just a community kind of general list of ideas. And the second on the list is this distributed load testing or distributed performance testing. And so the idea being that there are many, there's kind of 2 things. One, that many of the service meshes, their data plane is Envoy. So Envoy has enjoyed a lot of adoption by different meshes. Not all of them, but many of them. Envoy has long had the ability to, I think there's kind of a couple of topics. One is that there's a different project in here that talks about using Envoy filters. And actually, I don't think that we really described it in here. It's this 7th project. Kanishkar did file a Google Summer of Code application around Envoy filters and use of awesome WebAssembly, which is great. So there's that kind of a focus on Envoy, but this particular focus on Envoy is the notion that Meshery today supports 2 types of load balancers. So I'm just signing into Meshery. If I go over to the performance section in Meshery, it'll let me generate a bunch of, today, only HTTP load and blast that at an endpoint. That endpoint can be something that's on the mesh or something that's off the mesh. And so usually people aren't sending things to google.com, but usually it's, it's their service. And they could test that both on the mesh and off the mesh and see kind of the overhead and the difference in the response. And they're able to, there's a couple of points of extensibility in Meshery. One of those is around choice of load generator. We initially supported Fort.io. Fort.io is a Google project that was sort of born of the Istio ecosystem, kind of built in and around Istio. WRK and WRK2 have been around a lot longer. They're written in a different, this is written in Go. I think this is written mostly in C, if I recall. Maybe there's some Lua that's used here in WRK as well. And one of the reasons to support WRK2 is that there's this concept of omission, coordinated omission. It's just a difference in the way in which the statistics are calculated for the latency and throughput of the requests, the HTTP requests that are generated by these load generators, and how quickly the service, this service responds back. How those statistics are calculated is different between these, and there's a different. Some people have a certain opinion about how those are calculated, and so that's in part why we supported multiple. When we did this and we showed this to the Istio performance lead and the IBM performance lead for Istio, IBM was excited about potentially building, incorporating in their load generator, which is great. There's a load generator project, or there's a performance testing project within the Envoy community that we've long been aware of, and had actually originally reached out to these folks quite some time ago, but never really got traction per se. The name of that project is called Nighthawk. They call it a layer 7 HTTP, it looks like HTTP performance characterization tool. Now, there's a couple things, there's something I want to mention before we talk more about Nighthawk, and that's that Meshery supports generating load over HTTP. But really, this is one of the areas that Meshery will go deep on, one of the areas of functionality that people will look to Meshery to as a tool, as a unique tool that does service mesh specific things and does things around one of their prominent areas of concern, which is trying to, it's not just simply trying to understand how much is the service mesh costing me, like, how much is what's this overhead? It's that, but it's more in context of understanding and characterizing how much value the service mesh is providing me and now tell me how much overhead that value costs. Because otherwise, if you're just looking at overhead, you're kind of looking at it in a vacuum. It's like, well, there's 50% overhead. Okay, well, was that good or bad? Okay, or how much does that mean to me? There's actually these two questions we want to answer. And actually, the answer to Shivai's question is a little bit of what I'm describing right now, but it's also, Shivai, the fact that what we want to do is create a design spec and start writing down all the stuff that I'm saying right now and writing down your guys' ideas and approach and perspective. But I'll verbalize some of this and give some context. That it's kind of interesting. There are two. If you think about this analogy for a second, every one of us is a consumer. Every one of us goes to the store, buys something, or we go online and buy something, and some of us buy stuff from Amazon.com, which is a real shame, since AWS is not the most friendly cloud. As a consumer, there are kind of two things I consider that you would, and feel free to speak up and interrupt me here, but two things that I consider that you would ask yourself when you're trying to understand whether or not you should make that purchase. There's two ways in which you come to figure out, you come to assess whether or not you're getting a good deal. One of those is just your own internal assessment of the value of the thing that you're purchasing and how much it's going to cost you to get it. You usually have more information than just that. You have information about other similar products and how much they cost, what value you perceive that they give you, their name brand, any implicit goodwill towards that name brand, etc. Is it a luxury item? Is it on the cheaper end? That kind of a thing, But that's one sort of measure, just like, hey, what value is it giving me? Hey, this service mesh is costing me 50% more memory footprint. I'm okay with that because it's giving me so much value. I feel like that's such a fair trade. For some people, that might be the answer. That's one signal. A second signal is the having other data, and Meshery provides, or will be providing this very much so. And it's having other data like, well, right now the value that I'm getting, it's costing me 50% more memory footprint. Okay, it feels like that's okay. I'm not really sure because I can't really compare that to anyone. I can go to my buddy over there and say, hey, how much memory footprint is your service mesh running at? And that would help, right? Like if you had a bunch of other people to compare to, well, Meshery, every time that someone runs a test, so long as they have their preferences set to send their performance results, the project collects those. If you go to meshery.io and go down, you'll see that almost 700 people or 700 tests that have been run have been shared, those results. And as soon as we amass enough of those that we can get some statistically interesting analysis, we'll do that and we'll publish that analysis and we'll tell people, hey, you know, according to your environment, your setup, the service mesh you have, the configuration that you have, no, you're getting ripped off. Like you should only have 10% memory footprint overhead, or whatever it is, or just giving people a lot of that type of information. It's kind of hard to do because there's so many variables for the types of environments that can be run. But the more of these tests that are run, the more public service that we can do for people about indicating to them whether or not they're doing it right, whether or not they're running their infrastructure well or not. For some people, the 50% overhead in memory is totally worth it because they're asking the mesh to do so much more maybe than their neighbor's mesh is doing. So in context of distributed performance testing, distributed load generation, it's those kind of signals and answers that's the value in part that we're trying to provide to people. There's a bunch of other questions that get answered as part of this performance testing and part of distributed performance testing. Those questions are things like, how well does my service do under this load? And not just load from one source, but multiple sources, because the reality is you're going to be receiving load from various places. Some of that load will be generated internal to the cluster from other internal services. Some of that load, a lot of that load will hopefully be coming from outside the cluster. It really just depends on what your applications are and your workloads are. But point is, today it's, while it is sophisticated in nature, what we're doing and providing in Meshery, it's still relatively simple compared to distributed load generation, distributed load performance testing. There are any number of other interesting questions that can be answered in doing so. And so recently, some of the folks on this call have gone out and initiated a conversation in a different repository under Envoy Perf. There's kind of two repositories that are performance related in the Envoy project. Envoy Perf, which I think is a collection of various load generation tools and Python scripts and that kind of a thing. And then there's Nighthawk, which I think is a near as I understand something of a custom built performance testing tool for Envoy, and I believe had been given prior thought in its architecture as to how Nighthawk could be run in a distributed fashion. That's great. Like it can be controlled over gRPC. Great. We loved Meshery. It would work very well to coordinate, a fleet of Nighthawks, if you will, over gRPC. It sounds, some very promising things about engaging with Nighthawk. One is that its output can be in the same format as FortIO's output. Great. That means that there's much less work for Meshery to do in terms of refactoring that output to be well formatted for display on the front end of Meshery. The other thing that was encouraging is that someone had mentioned that Nighthawk was designed to be. I guess one of the questions as we continue here is that we'll want to get clarification as to whether or not what Nighthawk's capabilities are right now in a distributed sense. If they're cognizant of one another, if there's any amount of coordination that they do. One of the probably the biggest asks, it's kind of two asks that we would have of Nighthawk. The biggest one being, in my mind, being that once that load is generated, the results are created by each individual Nighthawk. The biggest ask that would be nice for us is if that project facilitated coalescing of those results into a single result set. Or I should say maybe a single result set that where you can still look at those results individually, kind of one that's all combined and then one that's, and then each one individually. That's not the easiest of work. It would be nice if that project does that. So that's kind of an open question. So good. So I went off and talked about this for a long time. One thing that I consider that we should do is, go and create a, go and take the, this Meshery document template, make a copy of it, and create a functional spec to begin to capture some of the thoughts that you guys have already had on the project and outline, and we can then begin to share that with the Nighthawk community, or the Envoy community, and the Nighthawk project itself. Shivai, does that sound about right? Is that kind of what you were thinking?
Yeah, exactly. Like just to have a brief, starting discussion on this topic.
Nice. I'm gonna get us going a little bit here just by creating a new functional spec template. So as I do this, I guess, I'll ask, Kush and Shivai and others, anything that jumped out at you about the potential use of Nighthawk that I didn't just mention? Or maybe some of the goals that we're looking to accomplish with distributed performance testing? For my part, I'll say that it's kind of interesting to think that microservices have been around for a while and people have been moving to those in a big way. They've been moving to distributed systems, but I don't hear a lot about distributed performance testing. You certainly hear a lot about resiliency and scalability and verifying these things, doing some chaos testing, making sure that your apps are resilient, that they can withstand being ephemeral, that you're handling state in the right way. And there's performance testing that's done, but I just don't hear a lot about distributed performance testing, which I think is reality, right? Like your service probably generally very rarely receives load from just one source. What do you guys think? All right, I'm going to put a link to that now that I did all that work to create the document and give it a title. Yeah, so Shubham asked a great question about gRPC and TCP and maybe adding that support in the GSOC timeline. So I think there's kind of two answers to this question. And just to repeat it, the question was really an acknowledgement that within Meshery, I said that we only generate load for HTTP today, but there's been open issues and a desire to support generation of load for gRPC, for NATs, and for just general TCP. And yeah, and so that's an open roadmap. And Shubham was asking, hey, can we, or can we take that on and include that in part of the timeline for GSOC? The GSOC time frame just passed yesterday in terms of student submissions. And so, so technically, I don't think that we can. That's certainly something that we can take and look to accomplish in the same time frame in the community. And yeah, but yeah, right now it wasn't included inside the GSOC submissions, or I didn't see any submissions on that. That said, there are probably some submissions that I haven't seen. So yeah. So. What other thoughts do you guys have on this? This is certainly something that I'd want to like build up the momentum with, and keep begin to get a bunch of thoughts down, iterate amongst ourselves about how we think we might approach it, and then begin to socialize that with the Nighthawk team and see what they're thinking.
Are we sure that we want to go ahead with Nighthawk and not Vegeta? Because I have been seeing Nighthawk code yesterday, and the build system which they are using is Bazel. And one more thing, that they are completely relying upon Bash scripts and Python for the load testing. And also, Nighthawk maintainers mentioned yesterday that looking for distributed load testing. So it might take them 1.5 month to initiate multiple load testing feature in the Nighthawk. And coming to the integration with Meshery, I haven't actually used Bazel build. I don't think how much easier or how much difficult will it be to integrate with Meshery, which currently only relies upon Golang.
Right. Yeah. I don't know that people have had very good experiences with Bazel necessarily either. Yeah, Kush, it's a good point. Of what Mom 4K said here, it makes it, or what Jacob, I guess, said here, it may sound like Nighthawk doesn't yet support distributed load generation, and maybe what someone else had said above was slightly misleading, because it had sounded like it did. So yeah, it's a good point. If it doesn't, then yeah, maybe continuing forth with Vegeta might be the near term the best thing to do.
Also, Vegeta can support generating report in the JSON file format.
Nice. Okay. So that's helpful. The thing about it being JSON is that we would want to acknowledge that it still might need to be reformatted into
the graphs and the client-side query.
Right. So no, I guess, yeah, it's a good point. We shouldn't, it's not a foregone conclusion that that Nighthawk is the one to use. I should probably update that in the integration of something. I don't know. I just I think we'll think of a clever subtitle, but that's a good point. Another one is that, yeah, of the way in which WRK2, of the way in which Fort.io is included into the project, if memory serves, Fort.io is included as a library inside the same Meshery container, so inside the same Meshery build. That's great. WRK2 is included in the same Meshery container, although I believe it is sitting there as a separate binary or a separate process, not process, but a separate binary. So I don't think that we're building WRK2. This is something to go look at. Whereas I think we are incorporating Fort.io as a Golang library, but not WRK2, given that it's written in a different language. That's a good consideration. Ideally, that's a little bit of a point of, it's a little bit of a hassle, the fact that WRK2 is written in C or not written in Golang. That makes it kind of a pain when you go to do development on your local system. So I'm on a Mac right now. If I'm building Meshery and running Meshery on my local host, on my local machine, and I want to go perform a performance test using WRK2, I need to be running WRK2 in a container, not on my local host. Because the binary I think that we're using isn't compiled for my architecture. And so point is, that it's nice when, I think initially we had included Fort.io as a separate container, but after a while you start to get, Meshery as an application, there's this sort of cognitive overload that people get when they see that they're deploying an app and there's like, 10 to 20 something containers. The psychology of it is that they feel like it's a big app, and there's a lot more moving parts. And so, including Fort.io as a library, it was a good move. WRK2, so Nighthawk, you guys recall, I was saying off the top of my head, I think that it's in C. You guys recall what Vegeta is written in? C++, I guess.
Vegeta is written in Golang.
In Golang, nice, This is the one that had certainly looked the most promising in the past. And actually, to the extent, Kush, I think to the extent that if that JSON format is...
They have mentioned it in README. The report can be generated in various formats, including text and JSON.
Okay. Which is great. I suspect we'll need to manipulate it a little bit to make it the same JSON format so that the UI doesn't need to change. We'll want to, do that data processing in Meshery server. But this one actually might not be, like, to incorporate Vegeta as a non-distributed load generator, like in the same format that we support for IO today, it might be not such a big piece of work, like, because it's in Go, because we can manipulate that JSON, because there's prior art there in Meshery server. And that's great. Like, that might be something to just give some decent analysis to now, while we're still having conversations with the Nighthawk folks to see if that even, it's not like it would be bad to support Vegeta and Nighthawk. The reason that I lean into Nighthawk kind of as the default position is largely because it's the same reason why we leaned into Fort.io initially as well. It's because Fort.io is so close to Istio. It's because Nighthawk is so close to Envoy. So these are just, very natural relationships, very natural. It's a good environment and community for us to be in. But it doesn't mean that it's the right thing to do necessarily, or at least not the right thing to do initially. We do need to articulate some of the use cases or some of the ways in which the distributed load results would be shown. So as you're familiarizing with Vegeta, some of the questions that we'll need to look at are like, okay, well, if you're beyond just the formatting of the JSON and the ability to call it and invoke it, like hey, if Vegeta is run in a distributed fashion, does it coalesce? Does it bring back all of its? Actually, I think it does, right? It brings back all of its results into the same report. Is that a single report, or is that a report that you can? Can you look at a single report, and can you also look at the individual result sets from the different instances of Vegeta? Those kinds of questions would be good to know, because that'll have that'll bear some weight on how it is that we're able to expose those results in the UI, and then bear some weight on how it is that we end up storing those results as well, and are able to recall them. So it'll be kind of interesting because, yeah, I think it'll be interesting to go walk through some use cases about how you might want to be able to compare a distributed performance test. So on this particular topic, by the way, this is a good topic for spinning out something of a working group. I think that there's probably enough interest, and it's a meaty enough topic, the performance topic at large, to have a working group that meets probably once a week to focus the discussion just on advancing this initiative. To make that a productive discussion, working through the design spec for distributed performance testing, incorporating in thoughts from the things that you guys have put into your GSOC applications. And then also there's a very related concept here. If you're not familiar, and you might implicitly be familiar, but there's a specification that I'm hoping we will ultimately, the community will make a mark on, and it's this performance specification called the Service Mesh Performance Specification, SMPS, and it was originated at Google, and we've adapted it and iterated on it a little bit. So the performance specification is really just a YAML file. It's one of the repositories under the Layer 5 org, Service Mesh Performance Specification. It's a common format for describing and capturing performance benchmark tests and results. It doesn't have to be benchmark, but performance, whatever. It's a few things. It's these things. It's a YAML file that lets you describe what type of test configuration that you're running. So Kush, we were talking about performance test profiles, the ability to allow a user to create a profile. Maybe they want to run a soak test for 2 days under a certain type of configuration, and it would just be convenient for them to save that config. And so that's what this is about capturing what that configuration is, because that'll have an effect on what the results look like. Then about interrogating the service mesh and understanding its configuration, because you can tell the same service mesh to do a number of different things. The more that you tell it to do, the more overhead there might be. So understanding and capturing what that configuration is important. Understanding and capturing what size cluster you have, how big the instances are, how much memory you have, how much CPU and cores, and etc. That all will certainly affect the performance of your workloads, of the performance of your service mesh. And then ultimately, capturing the actual results, like the load that you generated and the statistical analysis that was done. And that's what this spec right here, this is an example, but this is the spec, and it kind of has example details filled in. The spec needs to be iterated on. It hasn't been a focus of this communities for a while. There is the beginnings of an implementation of this spec, and it's done in Meshery. So if you go in Meshery, you've run a performance test, you can go over and choose to download it. It's a YAML file that looks very much like the format that actually there's a copy of that format or an example of what that looks like in this repo. There's the results file. So the reason that I say it's the beginnings of an implementation of the spec is because right now that results file, if you download it, it'll only have so much detail. It has the statistical calculations for the test results of that performance run, but it doesn't have nearly enough other information. It says that the environment for this run was Kubernetes 1.15.5. How many nodes were there? How big were they? The Meshery implementation has only gotten so far. But I mentioned this because it's part of that performance management working group. This would be part of that discussion. There's one other related concept in that group, and that is the concept of a service mesh performance index. And we intend for that to be called Meshdex. How many of you are familiar with AppDex? AppDex is a bit dated maybe, or it's been around for a long time. It is an application performance index. It's an open standard for measuring the performance of software applications. So its purpose is to convert performance measurements into insights about, in this case, they're saying about user satisfaction, by specifying a uniform way to analyze and report on the degree to which measured performance meets user expectations. So they have this whole thing. So our point here is to really, once we've gotten a common format described, to then come out with a formula, a Meshdex formula for calculating the Meshdex of any given service mesh. Going back to what I was saying before about weighing the value of what you're getting out of your mesh compared to the overhead of what the mesh costs you. And that can be really hard to describe because you've got so many variables about what kind of environment it was, what version of the service mesh you were running, how it was configured, blah, blah, all these things. But if you put that into a formula and kind of boil it down to a simple number, like, hey, you're currently running your service mesh at an 87 or a .87, like what? Okay, that's a lot easier to comprehend and compare to others. Like, yeah, hey, others that are running a similar environment, they're generally running at a 92. Maybe you should maybe you should change something, or like. And part of what Meshery, so we want from Meshery to calculate that real time and tell people what that is. And that's in part what Kanishkar is proposing in terms of a potential WebAssembly project that he was considering, is to calculate that service performance index real time as an Envoy filter, a WebAssembly filter, is sitting there watching traffic. Watching that traffic, whether it's load that's been generated or just regular user traffic, and in real time calculating that index, and then Meshery showing that back to people saying, yeah, hey, this service mesh here, it's running at a 62 Meshdex. Maybe that's great, or maybe that's not. There's a lot of context that needs to go along with that, but these are the kind of industry standard setting things that this community is well positioned to make happen. So that service mesh performance index and the specification, I intend to, with your help, hopefully we would take that to either the CNCF or a different standards body and try to make that a thing. So there's a bunch of there's a number of things to kind of make your name on, so to speak. But we're very early days in terms of service meshes and their ubiquitous adoption. Eventually, within a couple of years, it should be the case that everywhere that you see a Kubernetes, you see a service mesh too. And if that's the case, we're talking about lots and lots of installations. We're talking about lots and lots and lots of people coming to learn what Meshdex is. Lots and lots of people coming to use Meshery because because it's positioned to be the industry standard tool for managing service meshes. Part of understanding that mesh dex number, if I was running a service mesh and it says, oh, you're running it in, a 73, okay, well, thank you. Like, what am I supposed to do about that? I hear you're telling me that's not so great compared to others that are running similar setups. What am I supposed to do? Well, you can use Meshery to give you some of those insights. You can run, you can validate your service mesh configuration against best practices. So right now, I'm not really running any workloads in my environment. So my configuration is just fine. But what we're doing here is we're running individual vettors, individual best practices vettors or validators that check for certain things. This vetter checks for conflicting virtual service hosts. Virtual services are an Istio-specific construct, virtual service. And the Istio adapter has like 9 or 10 of those built in. None of the other adapters have those built in. That's something that we'd like for each of the adapters to have, because different meshes have different best practices. We've gotten kind of started on that with Istio. So on that, I presented quite a few like topics and things that we want to get to. And I see people have been taking meticulous notes here, so that's great. But the reason that I went on and on about SNPS, Meshdex, etc., the need to support TCP and gRPC load generation and performance testing, because these are all kind of, and we also talked about the performance test profiles, and then actually Kush can tell us about the need for scheduled tasks, scheduled jobs, cron jobs. Thoughts? What do you guys think? I get the sense that everyone else enjoyed listening to my voice just as much as I did. Anyway, I'm excited by the fact that we're finally getting some traction. Yeah, Kush, were you gonna say something?
Like we can have cron jobs that would save a lot of time and a lot of working for the user or the clients of Meshery. Like there can be a service mesh and there can be a client who wants to perform performance benchmarking or the testing of the load generation. So by introducing the cron jobs, we can enable them to, like if they want to perform every day at 5:30 UTC, or like if they want to perform on every 1st of the month or every 15th of the month or any regular period interval, or they can also schedule the job for, like if I start a job and I schedule it for 8 hours later or 9 hours later. So like cron jobs are very useful and they can have a wide use cases for the Meshery.
Totally. Yeah, I completely agree. Hey, you might, it's not just continual performance benchmarking or validation against a baseline. Yeah, you're definitely going to want to do that because your environment changed, things change. You're going to deploy a new version of your app. You're going to want to test your performance again and again. But more than that, cron job or eventually policies inside of Meshery, they're going to become important because, well, hey, I just checked to verify that we're running my Istio config against best practices. It looks pretty good so far. But then, earlier today, I actually changed something. So am I still running best practices? Well, I don't know. Like maybe this should be running. Then checking and confirming. So there's another example of like, hey, yeah, something else that would be scheduled. Beyond that, at some point, we're going to want to have policies because at some point, as a user who gets savvy enough, after a while, I'm going to say, look, actually, I don't really like this better. It doesn't really make sense to me. I don't care. It's always red for us. Forget it. I don't want to see the little red notification up here. So I want to be able to configure my own policy that says, here's the things that are important to me. Moreover, maybe I learned something special or unique to my environment that I want for Meshery to check. So this needs to be an area of extensibility for Meshery for people to be able to build in their own best practices. The next O'Reilly book that I'm writing, and maybe with the help of some of you, is tentatively titled Service Mesh Patterns. And so it would include some of these best practices. So I'm going to bring up a slide real quick that just maybe share some of this activity to the extent that it's of interest to you guys. So service mesh patterns. The reason I'm bringing it up is to say within there should be that should capture a number of best practices, of which my intention would be that those would be probably embedded into Meshery adapters for the different service meshes. Okay, so as we go to wrap up, I think that there's a couple of things to be done here. So one is to embrace Vineet and say it's good to have you here, Vineet. So we're gonna. It's good that you jumped on the call as well. We're gonna get you engaged in the community. Two is to take the designs that empty doc that we have right now and begin to flush it out more. To me, that's in context of Vegeta and in context of Nighthawk, and trying to figure out how to, what it looks like for either of the two of them. Maybe we would end up with both. It seems like Vegeta is more near term, or is like lower hanging fruit. Either one of the two of them does bring out some additional use cases about helping Meshery identify where it is that you want to run those distributed load generators. So Meshery we'll need to I think to the extent that people want to do that load generation in cluster, like from within inside their Kubernetes cluster, that will be something that's relatively easy for Meshery to orchestrate, for Meshery to coordinate, because Meshery can go talk to Kubernetes and say, hey, go deploy a daemon set maybe, or go deploy this new deployment that contains any number of instances of Vegeta, instances of that distributed load generator, and then Meshery can send that new deployed application command to have it spin up and generate load and collect the load and do the things it needs to do. But there's some amount of that is not something that Meshery does today. Those are things that we need to capture in the discussion. So one other doc that I want to point out, I don't think most of you guys have seen. It's this Meshery performance management document. Let me put it into the meeting minutes. It's fairly well done. Here, let me put it into the meeting minutes real quick. And it talks about a number of the concepts that we've been discussing. So this performance management one, it talks about the fact that we're supporting the SMPS format, the ability to import a file using that format, like import a performance test profile. I think, Kush, that's probably even called out here in this doc, the need for such a profile. So this is a good one to review in context of what we've been talking about. Some of these things have been done. I think these things in green, not all of them in green have been done. This one hasn't. But this serves as a little bit, these are sort of mini user stories, if you will. This serves as a little bit of roadmap for non-distributed load testing, kind of performance management. So given that we reached the top of the hour on our meeting, maybe we'll stop here. Folks have got the links to these docs. These are good things to kind of go through, digest, comment on. Google is ready to engage on advancing that spec. A few of them are in our Slack now. Looks like Envoy folks were receptive. We need to clarify how far along Nighthawk is. I think it would be better to ask for that clarity in context of presenting them with a proposal, or kind of the Meshery design spec, if you will. So I'll certainly be helping there. Any other comments, questions, thoughts before we wrap up? Nice. Anyway, for my part, I'm excited about the fact that GSOC helped get us organized. So. All right. Okay. Very good. Good to meet you, Vineet. I'll catch you in Slack. I'll see you guys. Talk to you soon. All right. Bye, guys. Bye. Bye, Shubham.
Yeah, bye.